Names to formulas for binary ionic compounds. So what we're going to do is I'm going to write a name up here of a binary ionic compound, and then we're going to write the formula underneath. In between is our strategy for naming binary ionic compounds. All right? So Anjali, what is the name of the first one we're supposed to determine the formula for? Lithium fluoride. Step one is, and you're going to do this with me, right? Right here, right there, right here, right now. Step one, write the symbol. That's good. All right. So step one, write the symbol. So what's the symbol for lithium? Li. What's the symbol for fluorine? F. Now you understand I wrote fluoride because when it's in a compound we put IDE on the end. I said fluoride, but you were smart. You recognized, well, you're just talking about fluorine, right? So next thing is to write the oxidation numbers for these two elements. What's the oxidation number for lithium?
1.
It's a 1+, yes. Okay, it's a group 1. All of them in group 1 have a 1+. What's the oxidation number for fluorine? Fluorine is a 1-, lithium is a 1+. So that was step 2. Step 3 is sum the oxidation numbers on each side, writing the sum down at the bottom. So I've only got 1 here, so I got a 1+ down here, and I've got a 1- over here. Okay, so step 3. Okay, does a +1 and a -1 equal 0? Great, we're done. Okay, all we have left to do is to count the number of particles and write the formula. All right, so step 4 was, I guess, you got to figure out if they're. Step 4, you got to figure out if it sums up to be 0. If it doesn't, then you're going to have to do some other stuff. But these both sum up to 0, the sum of the sums, I guess you would say. And so now all you have to do is write the number of particles. How many lithiums do I have? 1. How many fluorines do I have? Just 1. So I just wrote 1, 1. Now some people say, Mr. A, do I have to write a subscript of 1 because there's 1? I said no. If there's only 1, we don't write the subscript. Right? But you'll see in a minute that if there's more than 1, then we do have to write the subscript. Okay? So step 4 was sums to 0, and step 5 is count the particles and write the formula. Okay? Let's do another one. All right, what's the second name you got on there? Magnesium sulfide. We write the symbol. What's the symbol for magnesium? What's the symbol for sulfur? Okay. Step 2, write the oxidation number. What's the oxidation number for magnesium? 2+. What's the oxidation number for sulfur?
2-.
Okay. Looks to me like another match made in heaven, right? Because if we bring this 2+ down and this 2- down, and then step 4, do they sum to 0? The answer is yes. Then we're done. We count the number of particles and then we write the formula. So what would the formula for magnesium sulfide be? MgS. Okay, and we're done. All right. So far, easy peasy, lemon squeezy. Maybe 3 will be a little more interesting. What's number 3? Beryllium? Chloride? All right, what's the symbol for beryllium? What's the symbol for chlorine? What's the oxidation number for beryllium? 2+. What's the oxidation number for chlorine? A 1-. Now things get a little more interesting. We got a +2 down here, and we've got a -1 down here. Do those sum to be equal to 0? No. So step 4, if they don't sum to equal 0, we're going to have to add ions as necessary. So what do you think I should do? Should I add a beryllium or should I add a chlorine? Well, if I add a beryllium, then this turns out to be a +4 and a -1. That was the wrong way to go, right? So if I don't add a beryllium, the only other choice that I have is to add another chlorine. All right? What's a -1 and a -1? No, it's a -2. Add two negative numbers, you keep going in the negative direction. You got it. Uh-oh, look at that. Now do they sum to 0? A +2 and a -2? Yeah, okay. So now all we have to do is to count the number of particles and write the formula with the correct number of subscripts. How many berylliums do I have? No. No. Look at this. Look, how many times did I write Be? Once. How many times did I write Cl? All right, so the Cl subscript 2 to indicate that I wrote Cl twice. Okay? Now it's really, really going to get crazy. Can you handle it? Oh, man, you better zip up your hoodie because here we go. What's the last one? Okay. What's the symbol for aluminum? What's the symbol for oxygen? What's the oxidation number for aluminum? What's the oxidation number for oxygen? Okay, I got a +3 down here and I got a -2 down here. Do these sum up to be 0? No, they do not. So what do you want to add? You want to add an aluminum or an oxygen? Okay, if I add an oxygen, then this 2 becomes a 4. Still doesn't equal 0. You want me to add another oxygen or you want me to add aluminum? Okay, if I add an aluminum, this becomes 6. Uh-oh, and that's still a -4. Doesn't add up to be equal 0, so I have to add another particle as necessary. You want me to add an aluminum or an oxygen? I add an oxygen. Right? Oh, 2, 4, 6. Look at that. Santa Claus has come to town. A +6 and a -6 equals 0. We're done. All right, Angeli, how many times did I write the aluminum symbol? 2 times. So I write Al and I use a subscript to indicate that I wrote it twice. How many times did I write the oxygen symbol? 3 times. So O subscript 3. Aluminum oxide's formula is Al2O3. Thank you for tuning in.